Good morning, y'all. So, as we are not in class today, I still want to keep moving. We are going to talk about similar polygons the next time we are in class. But today I'm going to give you a little bit of an abbreviated lesson here. Not too hard, not terribly difficult by any means. So first, let's talk about what similar polygons are. We've talked about similarity in the past already in reference to similarity statements. We are also going to use those as well when we're talking about similar polygons. But something important to note that with similar polygons, they have, so similar polygons have, what they have is that all of their corresponding angles are congruent. And their corresponding sides are proportional. So those are the two big important things to note, that they have corresponding angles that are congruent and their corresponding sides are proportional. Now, notice that I didn't say that their corresponding sides are congruent, because then that makes them congruent polygons, not similar. Similar is like they have the same size, they have the same shape, but one's a little bit larger than the other one. So we'll see this in our notes later when we're in class, this diagram, but I want to use this to kind of explain the concept of similar polygons themselves. So first, what I'm going to actually do is I'm going to make a similarity statement here. And how I'm going to do this is, first I'm just going to pick the first polygon that I'm looking at here. So I'm going to look at this first polygon over here and call it A, B, C, D. So A, B, C, D. And I want to state what polygon that it's similar to. Now, if you look at the diagram, they match up pretty well, right? So this one here, A, it matches up with E. Notice the 3 lines and the 3 lines. And then I could work my way over to B, that matches up with F here. And then I could look over at C, and that matches with G. And then I'd finally say that D matches with H. So I'm going to name it that similarity statement based on that. So A, B, C is similar. This little squiggly line means similar to polygon E, F, G, H. Now, I can go through and match up all of the angles that I have. So A to E, and then I have B to F, and then I have C to G, and then finally I'd have D to H. These are the corresponding angles. Now, a little more of an extension off of this similarity statement. Let's say, for example, you were given a similarity statement. You could use that to figure out what angles are congruent to each other. So here, I can tell that angle A is going to be congruent to angle E, just based on the similarity statement. And then I can also say that angle B is congruent to angle F. And then I would know that angle C is congruent to angle G. And then finally, that angle D is congruent to angle H. Notice my similarity statement kind of goes in order here. If I'm looking at it like A, B, C, A, B, C, D, E, F, D, E, F. So there's an easy way to kind of go through. Now, again, important thing to know is that corresponding angles in similar polygons are congruent. I'm going to write this out. Corresponding angles in similar polygons are congruent. So that's talking about the first part of our notes where I said that corresponding angles are congruent. Now, the other piece that I said was that corresponding sides are proportional to each other. There's a difference there between similar sides or corresponding sides being congruent and being proportional. And we've been talking about proportions and ratios at the start of this chapter here. So here are all of my proportional sides here. And if I match it up, I can kind of look at the side lengths themselves and say, well, AB, this side here, matches up with EF, this side over here. And then you could kind of keep going along the side, BC with FG, so on and so forth. Now, from this, these are our proportional sides. And with our proportional sides, let's say we were missing one side length, but we had 3 or 4 other ones, we would want to use these proportions, but we're only going to use 2 proportions. When solving. Not all 4. You only need 2 of the proportions. You don't need all 4. So for example, let's say that I knew AB and EF. I could set it equal to any of these. It doesn't have to be in order, so I could set it equal to DA and HE within the problem if I was solving for any of those missing sides. Now, one final thing to note before we look at an actual practice problem here is that the ratio of the corresponding sides is also the ratio of the perimeters and this is called the scale factor. That is an important term for us to know what a scale factor is. So the ratio of the corresponding sides is the ratio of the perimeters, and this is called the scale factor. So what that means is that if I compare one side of one polygon to its corresponding side of a different polygon, it would be equal to the perimeter of the first polygon over the perimeter of the second polygon. And then when I reduce that, that's what gives me the scale factor. And something to note from this is that this must always be reduced. If your scale factor is not reduced, then it may throw off an answer to your problem. So let's look at 1 or 2 of these examples. I've assigned this worksheet here as your homework, but I'm going to do a couple of these problems with you here so you can pause if you want to and try these problems and then come back and watch it, or you could watch me do a couple of these problems and then finish it out the rest for homework if you choose. So I'm going to start with problem number 2 here. It gives us a similarity statement that triangle PQR is similar to triangle DEF. This little squiggly mark here, this means similar. It doesn't mean congruent. Remember, this sign here, this means congruence. This little squiggly sign over here, this means similar. So PQR is similar to DEF. I'm going to mark each of the angles as it's given. So P with D, notice first and first, so P with angle D, and then I have Q with E, so Q with E, and then finally we have R with F, R, and F. So I'm going to go through this triangle and mark my angles, P, D, Q, E, R, and F. Now, one thing to note, with similarity, it does not mean congruent. So this would be wrong if I went around the triangle and started marking congruency signs like this. That doesn't make any sense because now you're saying that the two triangles are congruent rather than saying that they're similar. So do not do that. Oops, eraser's too big. I'll make it a little bit smaller here. Do not mark your sides as being congruent. Instead, what you can do, maybe you want to use a highlighter and say, okay, this side matches up with this side. And then I can go around and say that this side over here matches up with this side over here. And then we can say that the bottom of this triangle matches up with the bottom of that triangle. So maybe you want to use colors instead of putting tick marks along the sides, because putting tick marks again means that you're saying that those are congruent. Corresponding sides in similar triangles are not congruents, they are proportional to each other. So let's look at this problem down here. So we're trying to figure out what corresponds. And then we're trying to figure out congruent angles. So side QP corresponds to what? Well, QP is this one here, and it corresponds with this one here. So that corresponds with ED. And then I have side PR. That matches up with DF. And then RQ matches up with FE. Then as I look at the angles, angles are in fact congruents when we're talking about similar polygons. So angle Q would be congruent to angle E. Angle P would be congruent to angle D. And then angle R is congruent to angle F. So using that, I'm just going to slide down a little bit. You're going to do 3 and 4 on your own. But in 6, it wants you to use the similar polygons above and write a proportionality for each of the following sides. So if I look at my first triangle here, I can name my sides as, oops, zoom in a little bit. I have sides of PQ. I have QR, and then I have RP. So let's use our similarity statement, or we could use our picture above and kind of figure out what are the corresponding sides to create my proportionalities. So PQ matches up with DE. QR matches up with EF. And RP matches up with FD. Now you can use these to like kind of guide your thinking of, okay, so PQ is up here, it matches up with DE, kind of like I showed here. And then you could go QR matches up with EF, QR with EF, so on and so forth. So you can use a similarity statement if you're not given a picture to figure out what are your proportional sides. And then finally, problems that you're actually applying where you're trying to figure out, okay, I have a missing side, but which side should I be using to figure that out? So example number 7 here, I want to find the missing side lengths in each pair of similar polygons. So here I'm missing side x, which is AC in our bigger triangle of ABC. So I'm going to first start with the similarity statement. Triangle ABC is congruent to triangle XYZ. So A with X, A, X, B with Y, B with Y, and then I have C with Z, C with Z. So doing so helps me because now I can look at it and say, well, I know that A and B is going to correspond with X and Y. And then I can also look at it and determine that A and C would correspond with X and Z. So knowing that, I'm going to set up my proportional statement as AB over XY is going to be equal to AC over XZ. So those are two sides that are corresponding, and we can set up proportional ratios based on that. So here I've got AB, which is 25, over XY, which is 10, and I'm going to set that equal to AC, which is X, over XZ, which is 6. Now from here, I just have to solve for X. So I would simply cross multiply here. I'd get that 10X is equal to 150. And when I divide by 10, I get that X is equal to 15. So hopefully this helps you as you follow along. You can start, restop, rewind as many times as you would like. My assignment for you on this e-learning day is to finish the rest of this worksheet here that I didn't complete in this video. If you have any questions, please email me. I'll be around most of the day today. If not, have a wonderful day, and I hope to see y'all in class sometime